For today's lesson, I'll be covering the 6.5, the average value of a function. The mean value theorem for integral states that if f is continuous on the closed interval a comma b, then there exists a number c in the closed interval a comma b such that the integral from a to b of the function with respect to x dx is equal to f of c times b minus a, where f of c is the average value. The definition of the average value of a function on an interval states that if f is integrable on a comma b, then the average value of f on the interval is 1 over b minus a times the integral from a to b of f of x dx. Don't forget this is equal to f of c, which is also the average value on the interval. We'll be using this to solve for. So for our first example, we're going to take the average value of the function on the given interval. Our function for this problem will be 3x minus x squared, and our interval will be from 0 to 3. So in order to solve this, we're going to need a base formula or general guidelines more as to how to solve this problem. So for this one, I'll be using 1 over b minus a times the integral from a to b of f of x dx. So you can easily write this as 1 over 3 minus 0 times the 3x minus x squared dx. And then you would solve it as any normal integral would be. And you would get 1 over 3 times 3x squared over 2 minus x cubed over 3 from 0 to 3. That is equal to 1/3 times 27 over 2 minus 9 minus 0, which we plug in here. This will give us our final solution of 1/3 times 9 over 2, which will give us 3 over 2. So for our next problem, we're also going to still find the average value of the function on the given interval. This time our problem is 2x over x squared plus 3, and our interval is 3 to x. So we know the base formula, so we don't need to write it this time. So we're going to just already plug it in, and we're going to get 1 over 6 minus 3 from the integral from 3 to 6, 2x over x squared plus 3 dx. And in order to solve this, we're going to need to use u substitution. So for this problem, I set u equal to x squared plus 3 and du equal to 2x dx. This allows us to make the substitution 1 over 3 from the integral from 3 to 6, 1 over u du. And we know that the integral of 1 over u du is equal to the absolute value of u, and from 3 to 6, and still don't forget the 1/3. So now what I would like to do is I replace the u back with our original x squared plus 3, so that we get 1 over 3 times the ln of x squared plus 3 from 6 to 3. I would then plug in my values of 3 and 6 and using b minus a. So you would get, when you simplify, the ln of absolute value of 39 minus the absolute value of 12. And you know that using log properties, that subtracting two logs from each other is the same thing as dividing. So for our final solution, we will get 1 over 3 ln of 39 over 12. For our next problem, it gives us a table, and it says the table gives values of a continuous function, and it says to use the midpoint rule to estimate the average value of f on 10 to 40. And it gives us a table with x values of 10, 15, 20, 25, 30, 35, 40, and f of x values of 33, 24, 53, 50, 44, 37, 32 respectively. So for this one, we're going to be solving for the average we're going to be using the midpoint rule to solve the estimate of the average. So for our first step, we could say that the average of the function is equal to 1 over 40 minus 10, which is 1 over b minus a, times the integral from 10 to 40 of the function dx. And because we're using the midpoint rule, we can estimate with keeping the 1 over 30 and using midpoint 3 to solve. So what this states is that we can use the three middle values to estimate a value that we are looking for. So for that, I would say it's still 1 over 30 times, this time you want to say 40 minus 10 over 3, which is the average, is the extreme minus the lowest, times the number of values we're using, which would be f of 15, we're going to be using f of 25 and f of 35. These are the middle values right here. And what this is just stating to plug in or find out these f of values. So we get that we get 1 over 3 times 24 plus 50 plus 37. And that can just be easily simplified into 1 over 3 times 111, which is then is simplified even further